Good morning, all of you. Once again, a warm welcome to this sometimes cold hall. Today we have a very interesting sessions to start with in the morning, and perhaps this session would also remind us some of the very insightful thoughts which were given to us from yesterday's deliberations. For example, in the prayer which Naresh Kirti made starting the conference, which he quoted from the Bhriguvalli of Taittiriya Upanishad, there's an exclamation of this very happy seeker finally proclaiming that I am the food, I'm also the eater of the food. Later, Professor Matsusawa, in his lecture, talked about a major difference between us and the chimpanzees. The chimpanzees live in the here and now, me and the world, and we also have me, the world, and the you, the triadic relation. I guess the major problem of the self and the other is also an exciting challenge for us to understand our complex ways of experiencing, our complex ways of relating with other people, and our complex inner worlds. And this morning's session is going to precisely do that, which is present some of these different worlds. And we start with Professor John P. John, MD. He's a professor of psychiatry and the head of the Department of Clinical Neurosciences at the National Institute of Mental Health and Neurosciences, which is a premier institute in Bangalore. He will speak on auditory hallucinations in schizophrenia, a window to the conscious self and its aberrations. Professor John.
Good morning, all of you. Let's start with some spooky stuff today morning. It's about hallucinations. I work at the National Institute of Mental Health and Neurosciences, as Dr. Sangeetha Menon said, as a consultant psychiatrist, and I also do some research on neuroimaging, using multiple modalities of neuroimaging in patients with schizophrenia and dementia as well, along with a few other topics such as different cognitive states and meditative states and so on. So today I'm going to be talking to you about some of the work that we have been doing recently on looking at the neural correlates of auditory verbal hallucinations. I hope that most of you in this audience know what is auditory hallucinations. Auditory hallucinations, all of you know? Okay, if you don't know, let me just, okay, by the way, this is where we do our work, the image analysis work, and...
Give me a certificate, go on, give it.
Is it audible?
Don't.
Not audible? Huh? Okay, so this is a little sample of auditory hallucinations that the patients with schizophrenia experience. So now let's look at, before I move on into my speech, because there are lots of differing definitions of consciousness, I probably would attempt to lay out some definitions which I would be using during the course of my talk. So as I had mentioned, I would probably lay out some of the definitions of consciousness that I would be using during the course of this talk. So while we were listening to those voices, what was happening? We were attentive and we were aware of something that was happening in the external world. This is referred to as external awareness. We were also aware that we are the individuals who are experiencing those voices. So that is called the awareness of self. And the moment you heard those voices, you also had certain internal thoughts about voices. You were mentioning, is it real? Is it not real? Is there something in there? What is it about? What are they talking? What does that mean to me? So there is a certain amount of self conversations that would go on in your mind, and you are aware of even that. So that is referred to as a state of internal awareness. So consciousness is all of this. So consciousness is a quality of the state of awareness of self, or of being aware of an external object, which is referred to as an external awareness, or something within oneself, which is an internal awareness. So, as the saying goes, anything that we are aware of at any given moment forms part of our consciousness. So now, what about self? So what is self? A self is a person's essential being that distinguishes them from others. Especially, self is considered as the object of introspection or reflexive action. So beyond self, external awareness and internal awareness, there's something called as meta-awareness. Meta-awareness refers to being aware that one is self-aware. So thus we see that consciousness has four components. One is the external awareness, the second is self-awareness, third is internal awareness, and fourth is meta-awareness. So all of us know that we are not only aware, but we are also aware that we are aware. So this is what is referred to as meta-awareness. And if we look at the levels of consciousness, we can see that there is a pyramid which goes from unconsciousness, that is being non-responsive to the self and environment, to consciousness, which is focusing attention on the environment. Predominantly what is being usually referred to as consciousness is your ability to engage with the environment and to process incoming external stimuli. And then there is self-awareness, as we had discussed, and then there is meta-self-awareness. So in psychiatry, in psychiatric disorders like schizophrenia, what we are dealing with is not the bottom of the pyramid, but abnormalities in self-awareness and meta-self-awareness. We'll come to that subsequently. So there's something, okay. So when we are experiencing auditory hallucinations or any voices or anything in the environment, there are certain things that occur within our brains. So let's see what are these the brain correlates of an external perception. So to experience any percept, first of all, we need to be awake. I hope that all of you, despite all these skirmishes and goof-ups happening here, I hope all of you are still awake. So this is mediated by the ascending reticular activating system. And then I hope all of you are attentive to what's happening on that screen. So this is mediated by the attentional network and the executive network in the frontal lobes. And then you are seeing something on the screen, so your visual brain regions should also be activated. And then you understand that this is something very important to which I need to pay selective attention to as compared to whatever is happening around me, whatever bodily sensations I might be experiencing and so on. So that is referred to as the salience network. This network that mediates this is called the salience network, which involves the connections between the anterior insula and the anterior cingulate. And then we have whatever we are perceiving, we match up with whatever is already stored in our memory through the memory regions in the medial temporal lobe. And then, as I had mentioned earlier, we are also aware of all the thoughts or other experiences that we are experiencing internally as a result of the visual perception. And this is mediated by the internal awareness network on the medial side, on the sagittal side of the brain. And finally, we also are aware that it is we who are experiencing the percept and not any other. So this is referred to as the self-agency. So you can see that consciousness involves multiple brain regions working in unison. And of course, the finer details about the neural correlates of consciousness and how all of these brain regions work in unison to help us experience percept as a whole is not fully elucidated, but we know that there are these brain regions that work in unison. So now, what happens in schizophrenia is what the object of our research is. So how is consciousness affected in schizophrenia? As I had mentioned, patients with schizophrenia are overall conscious in the usual sense of the term, but then the abnormalities of consciousness in schizophrenia occurs at the self-awareness or the meta-awareness level. So before going further, I would probably, for those of you who are not familiar with schizophrenia, I'll explain what is schizophrenia in slight detail. Schizophrenia is a condition that is characterized by various kinds of symptoms referred to as positive symptoms, negative symptoms. Under positive symptoms, you have delusions, hallucinations, which most of you would have probably heard about, and you also have disorders in the way they speak, or the way in which they act, or the way in which they express their emotions. And then there are negative symptoms characterized by withdrawal and not socializing with people and not motivated to do work and so on. And then you have cognitive deficits. They have deficits in the way their brain functions, in their ability to attend, the ability to memorize things, or the ability to do higher order executive functions. And then there are other symptoms as well, all of which leads to the social and occupational dysfunction that significant social and occupational dysfunction that these patients with schizophrenia suffer from. Now, the concept of schizophrenia was described formally around the turn of the last century by Emil Kraepelin, who described it as dementia precox, that is, dementia occurring at an early age, and he described it as a disunity of consciousness, something like an orchestra without a conductor. Now, the term schizophrenia was introduced by Eugen Bleuler, who referred to schizophrenia as a condition characterized by splitting and dissociation of the whole personality. So there is a disintegration of a personality, and thus the personality forfeits its natural harmony. Now, Joseph Berzé, who is a contemporary of Emil Kraepelin and Eugen Bleuler, was the first person to describe schizophrenia as a basic alteration of self-consciousness. He referred to schizophrenia as a peculiar change, a diminished luminosity and affectability of self-awareness. So, as I had mentioned earlier, schizophrenia does not affect consciousness in the commonly used sense of the term. You see patients with schizophrenia, they are awake, they are walking around, they might look quite conscious to a person who is not aware that this individual is suffering from schizophrenia. However, as I had mentioned, it does affect self-awareness and meta-self-awareness, and patients with hallucinations and delusions have been known to have aberrant or deviant self-awareness, while those with negative symptoms who are not adequately interacting with the environment are referred to as having retarded self-awareness or meta-self-awareness. Now, coming to the subject matter of hallucinations, as all of you might know, is the awareness of a percept. It might be a visual percept, it might be an auditory percept, it might be a tactile sensation on your skin, or anything. An awareness of a percept in the absence of a real stimulus. For example, a person listens to some people conversing, discussing, even when there is no one in the environment who is responsible for that stimulus. So, voices constitute the most common type of hallucinations in schizophrenia. Patients with schizophrenia complain about voices. They are able to hear voices. So, therefore, auditory hallucinations are a good model to study the neural correlates of aberrant conscious awareness of a percept. As I had mentioned earlier, there are certain brain regions that are usually involved in the awareness of a percept. So, if we study the neural correlates of hallucinations, wherein there is no real stimulus which causes the percept, we might be able to delineate which brain regions are overactive, which brain regions are active when they are not supposed to be, which could underlie the experience of auditory hallucinations. And in turn, it could also help us further our understanding of the neural basis of disorders of self-agency or the self-disorder. As I had mentioned, self-agency is responsible for our self-awareness, that we are the persons who are experiencing the percept and no other. I will not even attempt to play out the auditory hallucinations here. So it's just to say that there have been various studies looking at the functional imaging correlates of auditory verbal hallucinations. They can be broadly divided into trait studies and state studies. Trait studies means people who are having schizophrenia who have the experience of auditory hallucinations are suggested to have certain brain abnormalities, and irrespective of whether they are experiencing hallucinations or not, at the time of imaging, the studies would attempt to find certain brain abnormalities in such individuals. State studies refers to fMRI studies conducted during the hallucinatory episode. So these are referred to as capture studies, and therefore they directly measure brain activation associated with the onset of hallucinations. Now, this is a review of some of the findings of existing studies. They have shown that there are regions like the left inferior parietal lobule, left hippocampus, parahippocampal regions, left superior temporal gyrus, globus pallidus, Broca's convolution, and so on, right anterior insula, and so on, which are overactive in these individuals with schizophrenia. But there are certain problems with existing studies in schizophrenia. Most of these studies, as I had mentioned, are trait studies. They have not attempted to capture the brain activity during the experience of auditory hallucinations. Many of these studies have also looked at what happens in these individuals with hallucinations during the resting state, and they are just resting. But there's no way for us to ascertain whether in that resting state, during the fMRI study, they were indeed experiencing hallucinations. So we have tried to develop a paradigm wherein we are trying to capture the brain's function during the experience of auditory hallucinations. And to the best of our knowledge, except for a couple of studies who have required the subjects to press a button in the fMRI scanner while they are experiencing auditory hallucinations. So squeeze a rubber ball which is connected to the system while they are experiencing auditory hallucinations. Again, we have, it's quite unpredictable in its acquisition, and there is no objective way of quantifying whether the patients indeed were experiencing auditory hallucinations. So to the best of our knowledge, this is one of the initial attempts to develop a paradigm to capture the brain correlates of the auditory hallucinatory experience inside the fMRI gantry. So this task we have referred to as attentional modulational task. It comprises of three conditions. The first condition is called the free attention condition, wherein the subject is asked to keep his eyes at the center of the screen and not pay attention to anything in particular, while an abstract monochromatic figure changes in the center of the screen. At the end of this task, the subject is asked to press any button of their choice. There are certain response buttons inside the scanner. The next is referred to as a visual attention condition, wherein we attempt to take the attention away from of the patient with auditory hallucinations from their auditory hallucinations, so that they are engaged in a visual attention task. Again, they are asked to keep the eyes on the center and count the number of times the pattern on the screen changes. So how many times has the pattern changed? 3. Including the first one, it's 4, so the pattern has changed 3 times. So patients would be trained prior to the fMRI task. So, and then the third condition is a hallucination attention condition, which is administered only in patients with schizophrenia. Healthy subjects obviously do not have the auditory hallucinations. And the same, the images flash on the screen, and the patients are instructed to focus on the hallucinations and not to focus on anything else. And at the end of the particular block, they have to press another button indicating whether they have listened to experience a hallucination at least 50% of time during the previous block. And only those patients who have experienced hallucinations during the course of the fMRI acquisition would be taken up for further analysis. And of course, they would be compared with those individuals who have not experienced the hallucinations during the fMRI acquisition. And these are the image acquisition parameters. I will not go into it, go into details. It was acquired on a 3 Tesla scanner, and this is a description of a typical subject with schizophrenia. This is one of our 7 subjects with schizophrenia. Was a 22-year-old male with a history of 10 months of illness, characterized by second and third person auditory hallucinations. Second person auditory hallucinations refers to voices talking directly to them, and third person auditory hallucinations refers to voices conversing and referring to the individual in third person. And he also had elements of running commentary, some voice giving a running commentary of all his actions, like how you listen to a running commentary of a cricket match or a football match. And he also had persecutory delusions and thought broadcasts. He was diagnosed as having paranoid schizophrenia, and he was not on medications at the time of acquisition. These are the brain regions that we have considered to study the connectivity of the different brain regions during the experience of hallucinations. These brain regions have been taken from previous studies of the neural correlates of perception, as well as all the previous studies that have suggested certain brain regions to be affected during, in people with auditory hallucinations. This is the pipeline of analysis. My PhD scholar Pravesh, who is here, who is a Niaz Mani Bhaumik awardee, who's been largely instrumental in carrying out this analysis. fMRI time series undergoes a series of pre-processing steps, and the time series from each ROI, that is region of interest, is extracted, and there is a correlation between multiple regions of interest is calculated, and then it is Fisher transformed, and a one sample t-test was conducted to find which are the significant connections, and then maps are generated based on the t-statistic, that is the connections which are significant, and also based on the extent of correlations between the different brain regions. Now let's look at the results reasonably quickly. So these are the brain connections of healthy subjects during the free attention condition. So these are the frontal regions, these are the insula, this is the superior temporal gyrus, which is the auditory cortex, these are the memory regions, and these are the regions, the parietal regions involved in self-awareness and self-agency, and these are the visual regions. I will mark it again for you. So the frontal regions are referred to as the central executive network and salience network. Frontoparietal connections are involved in attention. The visual network is involved in visual perception. The medial temporal structures involved in memory. And the medial structures, the anterior cingulate, medial prefrontal cortex, thalamus, and the medial parietal lobe, they are all involved in self-awareness. And so you can see that the major brain regions that are involved in attention and perception, because there are, this is the free attention condition, those visual images are flashed across the screen, the subjects are perceiving the stimuli on the screen, so they are, all the brain regions that are involved in visual perception, that is the frontal network, the frontoparietal network, the visual network, and the memory regions, as I had mentioned earlier, and the internal awareness regions, they are all activated. Now, what happens in patients with schizophrenia? As you can see, as compared to the previous slide, I will of course show you a comparator slide later, the connections, overall connections between these brain regions are a little sparser. And the major connections are there, the frontal connections, you can see that, these red regions are regions that have multiple connections with, red nodes are nodes which have multiple connections with the neighboring and distant nodes. So all the major regions, including the prefrontal cortex, the insula, the internal awareness, the thalamus, and the precuneus are all activated along with the visual regions. But what is shown here is that patients with schizophrenia, during the free attention condition, they have an excessive connection between the superior parietal lobes on the left and right regions. Is that 10 minutes warning? I'm almost completing, I'm almost done. Sorry, yeah. Is it a hallucination? Yeah, or maybe. Yeah. All right. So this is the one difference that you see even in the free attention condition. So now, comparing the healthy and schizophrenia subjects, you can see that schizophrenia subjects had more sparser connections. So their connections are probably not as strong as the connections in healthy subjects during the experience, during the perception of a visual stimulus. And all the major regions are activated in healthy subjects, as you can see, the prefrontal, all of this, and in schizophrenia subjects, even though there are sparser connections, there is one connection between this node and this node, which is a superior parietal lobule. There are two lines here. One line is between the precuneus on both sides, which is important for internal awareness, and these connections are stronger in patients with schizophrenia. Now let's look at what happens during the visual attention condition. During this condition, as I had mentioned earlier, the subjects are engaged in the visual task and trying to see with focused attention how many times the pattern changes. As you have seen, it's not very easy, so they have to give a lot of attention to this task. So during that condition, in healthy subjects, as you can see, the visual regions are quite active, and again, there is connection between precuneus, but not between these two nodes, and the frontal connections and the medial connections are, as usual, activated. What happens in patients with schizophrenia? You can see that the visual connections are not as strong, even though there are these brain regions, these are visual regions, these are activated. But again, the connection, that you see two lines. One line is the precuneus, which is the internal awareness, and the other is the left superior parietal lobule on both sides, which are hyperconnected. Again, to compare the visual attention connectivity map between patients with schizophrenia and healthy subjects, what stands out is the connection between the superior parietal lobule on both sides. As I'll come back to superior parietal lobule later, but we had seen that superior parietal lobule is perhaps one of the most important structures of underlying self-agency. That is, I am the person who is experiencing this, I am the person who is responsible for my perception and not somebody else. I will skip this. This is just a comparison between the free attention and visual attention in healthy and schizophrenia subjects. As you've already seen, again, this is the one connection which differentiates between healthy and patients with schizophrenia. So this is the hallucination attention condition in all the 7 subjects with schizophrenia. So this is a condition wherein they are asked to focus on the hallucination. And as you can see here, again, the superior parietal connections are pretty strong. And then there is a strong connection between the superior parietal lobule and the inferior parietal lobule, and the left superior temporal gyrus, which is the auditory cortex, which is involved in auditory perception, is red now here. That means that it is showing lots of connections with neighboring nodes. And you can see that there is an asymmetry between the left and the right superior temporal gyrus. The left superior temporal gyrus is involved in auditory perception. Of auditory verbal perception. So you can see that during the hallucination attention condition, there are further changes. So this is again, just to highlight what are the difference between in patients with schizophrenia during the free attention condition, the visual attention condition, and the hallucination attention condition. You can see that in the visual attention condition, there is no asymmetry in the connections of the superior temporal gyrus, whereas in hallucination attention condition, there is indeed a difference. So I have 5 more minutes. Okay. So we have, amongst our 7 patients with schizophrenia, we've had 4 people who were hallucinators who reported that, they experienced hallucinations during the course of the fMRI acquisition, and 3 who reported not experiencing auditory hallucinations. So we try to look at a preliminary difference between these individuals. As you can see here, the hallucinators, you see a tight connection between the superior parietal lobules connecting to the inferior parietal lobule, and strong connection in the left superior temporal gyrus of the auditory cortex. Whereas in the non-hallucinators, this connection is between the precuneus. This is not the superior parietal lobule, as you can see here, and there are no increased activations in the left superior temporal gyrus. So this is by no means a confirmatory finding. This is a sort of a descriptive finding on the neural correlates of auditory hallucinations. We have just initiated work on confirming this initial hypothesis on a larger sample of patients with schizophrenia having persistent auditory hallucinations. However, I think some of the consistent results across multiple cognitive states give us a lot of hope that perhaps this is a good paradigm to look at the neural correlates of auditory hallucinations. So therefore, I have put together some of the networks that are involved in the normal visual perception, as you have seen. the central executive network, the frontoparietal network, which is involved in the external awareness, insula saliens network, which is involved in selective attention, internal awareness, then the thalamic filter, memory regions, self-agency, which is important, and the visual network for the visual perception. And what happens in schizophrenia potentially could be there is an increase in the connection in the superior parietal lobule, which is an aberrant connection, which leads on to auditory perception in superior temporal gyrus. I will not go into details of that. So there have been previous studies that have reported using different methods that superior parietal lobule could be one of the most crucial brain regions in evaluating self-generated movements and the role of superior parietal lobule in self-agency. This is a typical corollary discharge mechanism that is suggested for as a neurophysiological model of self-agency. Whenever the brain gives a command to the body, a particular part of the body to move, an efference copy of that same command is sent as part of a forward model. And then the action takes place in a part of the body, and then there is a real sensory consequence of that action. And then this is compared with a predicted sensory consequence based on the efference copy. And then if the predicted sensory feedback and the real sensory feedback matches, then it is considered as generated by self. If there is a mismatch, then it is considered as generated by other. This is referred to as a corollary discharge mechanism, and perhaps the superior parietal lobule could be an important seat of the corollary discharge mechanism as suggested by Feinberg and Frith. You just have to replace movement with a thought as an action, and a similar reference copy could be sent, and then there is a comparison which occurs in the superior parietal lobule when there is a mismatch due to aberrant hyperconnectivity, as you have seen in patients with schizophrenia. There could be a mismatch, and that the perception could be considered as generated by an individual outside of his own self. So the aberrant hyperconnectivity, therefore, of the bilateral superior parietal lobule could be strongly associated with the experience of auditory hallucinations. We have already shown previously that there could be aberrant activations. It's not all hypoactivations in patients with schizophrenia. There could be aberrant activations and deficient deactivations of the brain during cognitive task performance in schizophrenia. These are the last couple of slides. So this could have neurochemical basis, as explained by the glutamatergic abnormalities, hyperglutamatergia caused by NMDA receptor. NMDA receptor is a major receptor for glutamatergic transmission, and NMDA receptor hypofunction leading on to a hyperglutamatergic state in the brain, which could potentially lead on to the hyperconnectivity in certain parts of the brain. In our case, in patients with auditory hallucinations, could be in the superior parietal lobule. So therefore, to connect all of this, there could be a primary NMDA receptor hypofunction in patients with schizophrenia at certain crucial locations in the brain. We understand that it is in the GABAergic interneurons that are located either in the prefrontal cortex or in the subcortical structures. And this could cause a net cortical excitation, and which could lead on to an increased parieto-temporal activations during the course of experience of the auditory verbal hallucinations. So what are the implications of this for understanding neural correlates of conscious awareness? So the findings that we have underline the importance of self-agency in higher forms of consciousness, that is self and meta-awareness, as I had mentioned earlier. And superior parietal lobule could be a possible substrate of self-agency, and this is in keeping with, supporting the evidence generated from previous studies. And we propose potentially that, this particular brain region, aberrant hyperconnectivity of this particular brain region could be underlying the experience of auditory verbal hallucinations. I thank all my lab mates, especially Pravesh and Harsha, for work on this project, and all my collaborators and funding agencies for kindly funding my work. Thank you so much for your kind attention.
Sir John, and I'm sure there would be questions and comments which we would take up in the open session. May I now invite Professor Pratibha Karanth, my colleague, my friend, I should say, colleague, and a very distinguished speech-language pathologist. She is currently the program director and managing trustee of the Comdeal Trust, which was set up by her in 2003 at Bangalore for running the ComDeal program designed by her for children with autism spectrum disorders. She is also the series editor for Communicates, an indigenous resource provider for children with communication disorders. Professor Pratibha.
Thank you, Sangeetha, and good morning to all of you. I am primarily a clinician, and I will be speaking about children with autism spectrum disorders and our understanding of what goes wrong with them. Basically, I'm making a case for looking at the issues that children face physically and with reference to the environment, and in trying to understand that in order to help them, which is quite a contrast to the current popular theories of what goes wrong with children with autism. The background to this is that there have been very intriguing insights in the area of mind, brain, and consciousness, which have emerged from the neurological literature on adult patients who suffer from relatively common disorders such as strokes, head injuries, and dementias, as well as the rarer neurological disorders such as encephalitis lethargica or Cotard syndrome. I would like to mention here that while for the last couple of decades I have primarily been preoccupied with children with autism spectrum disorders, the first couple of decades of my career were as a clinician and researcher working with adults with neurocommunication disorders. And much of my work with children has in fact been influenced by my earlier experiences. Neurological illnesses lead to altered forms of consciousness and self, leading to many complex issues in the daily life of the individuals, including the notion of self and consciousness. The experiences and difficulties of these individuals raise a whole range of questions on the role of the brain in our notion of self, including the body and mind of the self vis-a-vis the external world and the others in it. However, while we know a fair amount and are increasingly learning extraordinarily intriguing descriptions of what happens with the adults, very little is known as yet about the possibility of similar issues being present in or underlying complex developmental disorders such as the autism spectrum disorders. This is important, and my shift from the adults to the children actually was influenced by the fact that we are seeing a steeply increasing incidence of autism spectrum disorders in children over the last couple of decades. It has skyrocketed from 1 in 10,000 in the 1940s, 50s, and 60s to the current figures of 1 in 68. And people are talking about a prevalence rate of 1% of ASD in children today. Yet, there is no agreement on the causation of ASD, and since there is no agreement on the causation, there is no agreement on the treatment or the intervention either. There is, however, a broad consensus that the basis of the disorder is biological and not psychological, as was presumed earlier. Now, the most popular current theory of autism has focused on the social component of the disorder, proposing that the core difficulty lies in the social domain. And this position is perhaps best represented by the proponents of the theory of mind, of which we heard a lot yesterday. And they propose that autism stems from the inability of the child or the individual with ASD in reading the minds of others. What I'm proposing is that we need to look at it from a broader perspective, and the difficulties that they have in reading the minds of others is perhaps to be found in the manner in which their bodies function. So the thrust of this presentation will be that the complex and myriad sensory motor issues faced by the child with ASD could well lead to a notion of self and consciousness that is at variance with the typical. Such an atypical notion of the self and consciousness could not only account for the deficient or atypical social component of the mind of the child with ASD, but also for the many characteristics of autism, both physical, behavioral. And support for this viewpoint, this is not research evidence as yet, but it is illustrated from clinical experiences with and self-narrations from individuals with the autism spectrum disorders. So let me, I'm sure that many of you have heard of autism and perhaps are aware of autism, but let me just quickly run through a brief introduction to autism spectrum disorders. These children are seen to be normal at birth and in infancy, but by the time they reach 18 months, 2 years, there are differences and oddities observed in them, even loss of some acquired skills like speech. If they had learned a few words, they tend not to use them anymore. These are noticed generally around the age of 18 to 36 months and become very obvious between the ages of 3 to 6 years. This is perhaps the most difficult period of a child or individual with autism spectrum disorders. The major characteristics, and these have been known as the triad of autism spectrum disorders, are behavioral oddities with lack of communication or inefficient communication and poor social interaction. The incidence, as I mentioned, has risen extraordinarily sharply in the last couple of decades, 2 to 3 decades. And currently the figure is quoted as 1 in 68. There has been a growing incidence, but there's also been a changing perspective of children with autism. In the 1960s, it was considered to be a psychological disorder, listed in fact under childhood psychiatric disorders, where the child was seen to be somebody who was self-content and did not want to interact with the external world, including his parents, including his family, and that this child was self-absorbed. Later in the 60s, there was also this blame game where the mothers were described as being highly intelligent women who did not perhaps care adequately for the child, and therefore resulting in this condition. By the 80s, the other signs of autism, the physical signs, were also being picked up, and they started being described as the pervasive developmental disorders. And in the 1990s and 2000 and beyond, we now address them as a spectrum of disorders, the autism spectrum disorders. I'm describing the current diagnostic criteria that I used, DSM-5, just published last year. And autism is today described as being characterized by deficits in social communication and social interaction, as well as restricted repetitive behaviors, interests, and activities. Now, this is very interesting because from the triad, it has now moved into 2 subgroups, deficits in social communication and social interaction. And interestingly enough, in the same DSM-5, there is a subgroup of children with communication disorders who have only the first characteristic, that is deficits in social communication and social interaction. So when they have the second, that is the restricted repetitive behaviors, interests, and activities, they are then classified as children with autism spectrum disorders. I would like to show you some of the characteristics of these kids. This is from our clinic. Toe walking, where the child is constantly walking on his toes. You see that he doesn't place his foot horizontally. And they're like this through the day. Rocking, another very common characteristic of those with autism. You see this little child sitting here? Head banging. Peripheral vision, mouthing and hand flapping. I'm afraid that maybe we need to get the light off one of these because the videos are not being seen properly. This is the same girl, you saw her doing this kind of a movement. A tendency to mouth anything that's given to her. The hand flapping, very characteristic of children with autism. Poor eye contact, no response to name call, poor sitting tolerance, poor attention. This is a child who came to our clinic from Maldives, and you see the interaction between his mother and himself. He barely responds to the mother's calling him or to her presence there. There is absolutely no eye contact. He refuses to sit in a place, refuses to interact. When forced to do it, very briefly. You will notice that the brief instant in which he gave some attention was when she sang a song to him. And then he's back in his own world. My early clinical experience working with adults, I have seen a lot of symptoms in these adults where, for instance, there are the aphasias, the alexias, the agraphasias, and basically these are loss of skills which these adults had. The aphasia refers to a loss of ability to speak or understand speech. Alexias refer to the abilities to read, and agraphasias, the ability to write. All of these in literate patients. But there are also the agnosias across different inputs, auditory, visual, tactile, where the patient who, subsequent to a stroke, loses the ability to distinguish between not only speech sounds, but also sounds in the environment. So a doorbell no longer has a significance of a doorbell. Or visual, looking at patterns, looking at pictures, and they're not carrying the same significance as earlier. There are also the apraxias, where in the absence of a motor deficit, the patient has a difficulty in executing a motor function. Often they do it voluntarily, but when they are, they do it involuntarily, but when they are asked to do it, they have great difficulty in doing it. And the classic example for the apraxia is of the man who was asked to say no by his clinician, and the patient kept trying to say no and got extremely frustrated and said, "No, I can't say no." So this is a classical example of the apraxia. Over the last 20 to 30 years, we have had increasing insights and autobiographical excerpts from children and adults with autism, which seem to suggest that they face a range of difficulties across the different senses. We've also known that they have difficulties in executing motor commands. Again, a difference between the voluntary and the involuntary. And a lot of this suggests that there are similar processes that are going on in them as we have seen in adults with neurological disorders. I'm just taking some examples from some published literature and from children that I have worked with. Temple Grandin is perhaps the best known votary of autism. She's now a professor of animal husbandry and veterinary science, but a person who struggled with autism in her childhood and then ended up writing and publishing a lot about autism. Yesterday, we are all very impressed with the chimp that, very nonchalantly pointed out to where the numbers existed in the screen after the screen had been changed. Temple Grandin has published a book called Thinking in Pictures, and she talks about how anytime she is asked about something or has to recollect an incident that happened in her past, it is like pulling out a video and playing it all over again, complete in every detail. So there are people with autism who have these kind of extraordinary visual skills, and I will illustrate some of them as I go on. Tito is a child that I worked with for about 10 years, from 1993 to the early 2002. Kali is another child who has been speaking about her autism and what it meant to her. Both Tito and Kali are non-verbal. And for about, Tito started communicating with me when I started working with him around the age of 4 years. He did communicate with his mother before that. Carly started communicating at the age of 14, and both had been diagnosed with severe autism and severe retardation. I will give you some samples of what they had to say when they, quote, broke through their autism. Krishna Narayan is another young man, an Indian man who was nonverbal and who at the age of 21 years wrote a book. And of course, we now work with hundreds of children with autism across the country and are gleaning insights to support what has been reported in the literature. Now, children with autism have issues in processing across the modalities: auditory, visual, tactile, olfactory. We know that they have great difficulty in listening and perceiving speech, listening to and perceiving speech. At the same time, some of them are extraordinarily gifted in perception of music. Visual, we've already covered the examples. Tactile, some of them can't bear to be touched. Okay, some of them want to be hugged all the time. Olfactory, some children with ASD will only recognize people by sniffing them. In terms of auditory processing, there is the auditory sensitivity. They cannot bear sound, so, pressure cookers, mixers, the child goes this way. Loud noises, the child goes this way. There is selective listening, and a lot of parents come and tell us, you call his name, as you saw in the case of the child the video that I presented, there's absolutely no response. But the child may be playing in another room and the favorite jingle comes on TV, the child darts immediately to the TV to watch the jingle. We think that there are some real difficulties in processing speech stimuli in real time. And this again is not something that we have seen a lot about in literature. When we work with other children, this condition is called specific language impairment, and there are theoretical debates as to whether specific language impairment is the lower end of the autism spectrum disorders. These children seem to have issues with auditory processing. So one of the interventions that addresses this is to start shortening the vowel lengths in the speech that is fed to them, and then they seem to function better, suggesting that there is a time gap in the processing of speech. Strengths in music perception, young children with autism are known to pick up falsely sung notes. They're very good in music appreciation, and there are increasing reports of these kinds of strengths. Visual memory, again, there are strengths, and possibly because of these very strengths, deficits in real-world functioning. A lot of parents report that the child is very good in remembering routes, maps, events. They pay a lot of attention to details. If a child has arranged a certain thing in his room, a lot of them are fond of picking up objects, say toy cars or toy whatever, and putting them in a line. And if there's even the slightest disturbance in them, the child gets agitated. Hyperlexia, or the ability to read without being taught to read, is also something that we see in children with autism. And if you see, there is a parallel between learning spoken language and hyperlexia. Typically, all of us are born with the capability of listening to nonverbal sounds, to speech sounds, And as we grow, we tune into the speech sounds in our environment and learn our languages, both initially to listen to them, to understand them, and then to speak them without being taught to do so. And then our brain deduces the underlying principles of the language, also the sound components of our languages, and we lose this ability as we grow. What happens with children with autism is that without being taught, they look at printed matter and they learn to read by themselves. And this is known as hyperlexia. There are difficulties in holistic perception. So while they pay a lot of attention to the detail, and even if the minutest detail changes, they notice it immediately, they seem to have a lot of difficulty in the overall comprehension of what this picture represents. Figure-ground relations, particularly when there is a moving object. A lot of children have difficulty with guessing the speed, guessing where this object is going to be, and resulting in accidents like road accidents where the child darts without paying attention to an oncoming vehicle. Avoidance of eye contact is considered the sign of autism, and this is also to do with the visual processing. There are tactile sensitivities to clothes, textures. Some children will just not have their shoes removed. They want to be with their shoes on. And this again, is related to the proprioception of the body, not wanting any clothes or particular clothes. Some do not want any clothes at all, or some will wear the same dress repeatedly and refuse to change it to any other dress. Resistance to being touched, resistance to being hugged, and some wanting to be hugged all the time. Avoidance, a lot of feeding issues. They are very sensitive to the texture of the food. So certain textures they will not allow you to take close to their mouth, and certain textures are all that they will eat. The social consequences of these are very many. They are unable to play interactive games with peers. They cannot engage in socially appropriate behavior. Often, there are all of these behavioral characteristics that I showed to you, which can come anytime, wherever the child is, and can last for long periods of time. Taking off clothes, all of these are signs of inappropriate social behavior that you see in them. Olfactory, I already mentioned that there are children with autism who will go around sniffing people instead of, interacting with them socially. There is also oral sensitivity and selectivity in food. There are certain items of food that they cannot tolerate in their mouths. And once they are okay with a certain kind of food, generally mashed, well-cooked food, they will not eat anything else. There is synesthesia, where there is an intertwining of senses. And in autism, you see all kinds of combinations: tasting color, seeing voices, smelling sound. And this is a poem from Tito, the child that I worked with. He says, voices of colors and voices of shadows, voices of movement and their echoes, voices of silence spun near or far, through spaces and distance soaking my ear. So there is evidence of synesthesia. This is relatively new, the recognition that children with autism also have motor issues. And executive dysfunction, there's a fair amount of literature on that. They also have issues in terms of the developmental skills, the gross and the fine motor issues, oromotor issues I've already mentioned, and the apraxias. What are the interventions? There are a range of interventions. Since we do not know the cause, there is no particular there isn't a single medical treatment for autism, though there are several experimental works that are going on, but generally the interventions provided as of today are these. And generally they are piecemeal. These are all people with different training, and the child with autism often has to go to receive this training. One other interesting observation that I would like to make is that now we know that how complex this picture is, how varied it can be. To compound the problem further, a particular child can have different sensitivities at different times, which means that he can be hyposensitive at a particular time and then be hypersensitive at another time. So that compounds the problem even further. Let me just illustrate their difficulties with the sense of the body. As I mentioned, Temple Grandin is one of the earliest perhaps to talk about this, and she went on to design what she called the hug machine, which puts pressure on the body. This led to an intervention method called hug therapy, where people would calm down children by hugging them. Now, this worked with a certain proportion of the children, but certainly not with the majority of the children. Occupational therapists now use the technique of wrapping children in blankets to calm them down. And we also have deep pressure and weighted vests, which the child wears. And this is also linked to the child who wants his shoes all the time on. The pressure of the shoe makes him feel his body better. I think this is the illustration of the hug machine that Temple Grandin designed. It is no longer really used. Instead of that, we use the weighted vests and stuff like that. There are many of the characteristics of autism which can be linked and explained in terms of this lack of proprioceptive feedback from the body, of the self. Children with autism are fond of drawing the outlines of hands, feet, and body, and I will illustrate this. All children are fond of looking at mirrors, but children with ASD are particularly fond of looking at mirrors, moving, outlining their body outline in the mirror. Playing with shadows, watching shadows is a fond preoccupation. Finger ringing, one of the explanations given by a child that I worked with was that when you ring the finger, you feel the extremities of your body. And that is one way of assuring yourself that you exist. Tito, I remember, howled every time he walked into my office and this was when he was about 4 years old, when he had to sit on a chair. Normally in clinics we have furniture that is suited for children's needs, but I was working with him in my office, and he would howl because he needed to feel his feet on the ground. And then we moved to working on a mat so that both of us were on terra firma. This was the example of the outline of the hand. A fond obsession, his hand, my hand, whosever hand that he could lay his hands on, he would want to draw them and look at them. This is again from Tito. When he was 9 years old, Tito published his autobiography, which was published by the British National Autistic Society. And on page 20, he says, he felt that his body was scattered and it was difficult to collect it together. He saw himself as a hand or as a leg and would turn around to assemble his parts to the whole. Watching a fan is again another characteristic of autistic children. They come into a room, they look at the fan, and they continuously want to watch a fan. Tito says he got the idea of spinning from the fan as he saw that its blades that were otherwise separated joined together to a complete circle where they turned in speed. Now this is an illustration. Sorry, I think this is a video made on Tito by BBC. Can I have the volume up, please? This was Tito when he was about 9 or 10 years old.
And end up thinking black. You can be sure to get frustrated. Time and again it happens to me, and I get quite helpless. Otherwise, why should I get up and spin myself? Spinning my body brings some sort of harmony to my thoughts, so that I can centrifuge away all the black thoughts. I realize that the faster I spin, the faster I drive away the black. When I'm sure that even the last speck of black has gone away from me, then I spin back in the opposite direction and pull the blue thoughts into myself. It depends on how much blue I want. If I want more blue, I have to spin faster. Otherwise, not so fast. It's just like being a fan. The trouble is, when I stop spinning, my body scatters. And it's so difficult to collect it together again.
I'm sorry, the video is a little distorted because you really see him spinning fairly fast. And then he reverse spins. And he's described this as saying that, again, that is when he feels that his body is as a whole. I want to show you another video which I seem to have skipped earlier. Please watch this.
Stick 7.
I'm going to do a drawing of New York City from the memory. I feel excited. It's a beautiful city. Lots of skyscrapers. My favorite is the Empire State Building. It's a brilliant building. It was so beautiful up there. Nice and sunny.
I would love to be in his mind to actually see how he sees things. Stephen was mute until the age of 5, so drawing was a form of his speech. This was his language. He has a phenomenal memory and is able to memorize cityscapes, landscapes, how many windows, floors, chimneys. To watch the ink touch the paper, it's almost like fine embroidery. You can actually see it develop. I never get tired of it.
This is it, it's done now. So I feel happy and good. I'm very proud of my work.
So this is another young man diagnosed with autism, mute till he was 5 years old. He's taken up on a helicopter ride for 15 minutes, watching the skyscape in New York City, and in 3 hours he draws it to perfection. He has done this with Rome, he has done this with London. Okay, and every time, not only is each building recognizable, but the number of floors, the windows in the floors, the trellis, the details are all accurate to the minutest detail. So apparently human beings also have these capabilities like the chimps. Okay, but there is something that is common between chimps and children with autism, where something is not quite right. Now this is Tito when he was in my office last year. He now lives in the US. After the British documentary, BBC documentary, he moved on to the US. But he visited us last year, and if you see, he is wearing long-sleeved shirts. We were trying iPad software that we had developed to help children who are non-verbal, and we were trying it with him. And every now and then he kept pulling his fingers into his shirt sleeve. And later when I probed, he said he gets distracted because he sees just his palms and his fingers, hanging around. Okay, and that distracted him, and therefore he needed to pull it back into his shirt sleeve, which means that he still has these difficulties with proprioception and he's still struggling with them. These kinds, I will not go into the details, but this is well documented in adult literature. So any of us, tomorrow if you have a stroke, we could have these kinds of symptoms of unilateral neglect, difficulties in spatial orientation, difficulties between the external world and our bodies. Now, these are seen as behavioral oddities in children with autism. The obsessions with sameness, lining up objects, clinging to routines, and therapy mats, which give them a boundary and how they enable them to calmly do their work. While these have been explained as behavioral oddities, I think another way of looking at it would be as coping mechanisms which the child develops on his own. This last video, again, I'm hoping this will work, of another child. It is important for you to understand, again, this young lady who is now a young adult, when she was mute, and until she's still nonverbal. She was diagnosed with severe autism and severe retardation too. And she discovered that she could communicate by typing into a keyboard. And then sorry, this will be the last one, and then I think I'll quickly conclude. But I think seeing this will raise issues about the self in autism and what it has to tell us about consciousness, awareness of the self and consciousness.
Through her torrent of words, Connie began to unravel the mysteries behind her often wild behavior. Like banging her head.
Because if I don't, it feels like my body is going to explode. It's just like when you shake a can of Coke. If I could stop it, I would, but it's not like turning a switch off. I know what is right and wrong, but it's like I have a fight with my brain over it.
Sorry about that. It seemed to work well with my laptop, but we had some issues here. Now, the questions that one needs to think about when we work with children with autism and try and understand what's going on with them is that, one, these are children who are born normally. They look typical. They're beautiful children like all other children. But as they grow up, they seem to acquire or exhibit a lot of oddities in their behavior, and some regress. Even the skills that they have learned don't seem to stabilize. What one needs to understand is that perhaps in these children there is no awareness, and as they write, some of them write later, there is no awareness that they are experiencing the world differently than all of us do. They try to meet the expectations of those around them in terms of learning the skills that all other children learn, typically shaped by their families. But they have no idea that the adults are experiencing the world differently. Finally, not just a double whammy, but a triple whammy, the adult has no way of knowing that this child is experiencing the world differently. Now, given all of this, how is it that the child can learn to function as a typical child? And this is the alternate view that we are proposing. There have also been, in the published literature, there is some of this coming. The neuroimaging results, in the last couple of years, people are looking at whatever you find in terms of the neuroimaging studies, earlier were interpreted as being deficits in social cognition and understanding the minds of others. There are some researchers now talking about whether this is a difficulty in understanding the self, issues with the self. There are other young adults who are Asperger's who did not have the gross difficulties that the children that I have shown you suffered from. But even these children write about issues such as these. The first one I will not go into because it's similar to the earlier ones that I've described. But here is a basic problem. This young lady now says, I also had another problem, though it was a problem I never understood until I was an adult. I thought it was the same for everyone. And what was the problems? I couldn't feel that I needed to go to the lavatory, so I had to think out when I needed to go. I didn't know other people had a signaling system that warned them at intervals before the need to go became urgent. I had no such system. I felt nothing. Okay. And we know, again, the published literature doesn't talk about the toileting difficulties that children with ASD have. Another poem from Tito, I think I'll skip that and come to my conclusion. Here then are individuals not with altered selves, like the adults with neurological disorders, where there was a typical self with brain damage, it gets altered, but born with it at some level. Again, I do not want to make it sound like what we see in the brain is the causative agent. We don't know. What we see in the brain may be a reflection of the difficulties that the child is having in learning to deal with the real world, and that may be what it is that we are seeing. We don't know as yet. There's a lot more work that is needed. Children with ASD possibly grow in environments and experiences that are unknown and alien to us. What then of their notion of self and consciousness and our expectations of them in terms of our notions of self and consciousness? I think this is the neuroimaging study that I mentioned. Hope lies with the baby experiments that I'm told are now being done, okay, with multiple ways of looking into the brains of children who are as young as 2 years old. So I'm sure we learn a lot more from these kinds of labs. But then we might learn that even 2 is not early enough. Because from birth to 2 years, there's much that the child learns, and we may have to go into an even earlier age. These are my acknowledgements. And for anybody who might be interested in this kind of work, thank you.